PROFINET, the new generation of data communication in the automation industry, is more flexible, more efficient, and faster. But how exactly does PROFINET work? What happens between controller, I/O devices, and switches? Comparing PROFINET with the Profibus technology will show this clearly. With Profibus, master and slaves are connected by one single line pair. There is a constant question and response relationship in which the master gradually checks on all its slaves. In road traffic, the Profibus technology would look like this. Imagine a street which only has a single lane for traffic. As a result, only one vehicle can go in one direction at any time. A van travels from a production facility to its first supplier and back again. It then travels to the second supplier and returns once more, and so on until it has visited all the suppliers. The process runs more intelligently with PROFINET. The master here is called the controller and is connected to the various network nodes by two signal line pairs. We therefore have a dual carriageway with a return lane. With the aid of switches, telegrams are sent intelligently and directly to the relevant I/O device without any diversion. This means that transmission operations are faster and more efficient than with Profibus. This technological progress is used by industry for fast and more precise processes because many more telegrams can be sent simultaneously. The resulting increase in traffic density causes a higher network load, which is mainly affected by the update rate, line depth, and network structure. The update rate is the time interval between the telegrams transmitted between the controller and the I/O devices. PROFINET offers high flexibility because the hardware configuration enables the update rate to be set individually in the controller for each network node. The rate needs to be based on the PLC cycle time and should in each case be set as high as necessary rather than as high as possible. For example, it is unnecessary for the van to travel to the production facility every millisecond if the facility only needs new material for the final product every 4 milliseconds. The flexible update rate means that at various points in the network, the telegram traffic and therefore the load on the network are more difficult to predict. Switches transfer the telegrams intelligently, but, like traffic lights on our roads, are also an obstacle for the telegrams. How do these intelligent traffic lights work? Switches operate almost exclusively in store and forward mode. This means that telegrams are completely checked for CRC errors or fragments prior to the routing. If there is an error, they are deleted. As a result, a time delay can be expected at each switch transition. If the planned arrival of the telegram is delayed, this is referred to as jitter. Line depth is important here. The line depth specifies the number of transitions between the I/O device and the controller. In other words, how many traffic lights the vehicle passes through on the way to the production facility. When designing a network, it is important to plan the line depth in relation to the level of the update rate. Profibus mainly uses a line structure. PROFINET, in contrast, applies a mixture of star, tree, line, and ring structures. Cable lengths of max 100 meters between network nodes provide reliable data transmission. The PROFINET technology makes it possible to change structures in a breath. Constant monitoring in the form of an up-to-date topology plan is therefore essential. The overview of the actual wiring enables any connections between the network structure and a diagnosed error to be detected much faster. Here is an example of data communication in real time. The PROFINET technology enables a data transmission rate of 100 megabits per second. This means a transfer of up to 100,000 telegrams per second. The telegram traffic is often greatest between the controller and the first switch. However, Acyclic data traffic also creates a load on the network. This includes data packages from TCP/IP traffic caused by a touch panel, data from production data acquisition, or even SNMP requests. TCP/IP packages are as fast as PROFINET telegrams, but larger, like a 40-ton lorry. Therefore, it puts a strain on the transmission routes for a longer time. Although, in principle, the PROFINET communication has right-of-way at network nodes, it may be slowed down by the TCP/IP communication. The load ratio between PROFINET and the TCP/IP communication should therefore be specifically adapted. This heavy load affects the behavior of the switches. Each switch has memory capacity, so-called queues. When traffic is heavy, the queue provides interim storage for the telegrams. If the load remains high in the long term, the queue becomes full and all new incoming messages are lost. These so-called discards are a sure sign of unstable communication operations. When the traffic load decreases, the queue gradually sends the stored telegrams to their destination. This is because only one telegram at a time can be sent on each section of the route. The network status should be tested from time to time, e.g., with a network scan, or monitored constantly in order to provide advance warning of failures. Please note that the telegrams sent by an active diagnostic tool are an additional load on the network. A passive analysis tool is therefore recommended for permanent diagnostics. The structure of a PROFINET cable has the big advantage of fast communication transmission. However, compared to the Profibus cable, the two adjacent signal line pairs are also more prone to crosstalk. Data transmission can therefore be seriously disturbed by a cable pinch, and quality measurement in accordance with the cable category is therefore very important. Awareness of all these interconnections enables the effectiveness, speed, and productivity of a machine or installation to be influenced and safeguarded on a permanent basis.